Way too much of my energy. I look up.
Okay, I think we will begin our roadshow today. So thank you everyone for joining us on this really rainy day. Yeah, I appreciate yourself coming in person today. So for this Smartboard challenge, we actually have roadshows running the whole entire month of June and as well as first week of July. So in these roadshows, we will have the opportunity to speak to our corporate partners who have actually come up with these innovation opportunities. So my name is Jeline. I'll be the moderator for today. Yeah, so for some of you who might not be familiar with what SPC is, it stands for Smart Port Challenge, and it's a flagship event of PSA71, which stands for Port Innovation Port Innovation Ecosystem Reimagined at Block 71. It's a program co-founded by MPA as well as NUS Enterprise. So this year we actually have 15 innovation opportunities and supported by 22 corporate sponsors and organizations. So how this roadshow is going to be run is the first hour, we'll be hearing from the corporates on the innovation opportunities, and we have two today, and we will be followed by a Q&A session, followed by a networking session for those who are present with us today. Yeah, so today we have representatives from PSA, Boon Teck and Jonathan. So thank you for joining us today. Yeah, so to kick off the roadshow, actually we'd like to show two quick overview videos to elaborate a little bit more about the innovation opportunities. Yeah, so could we have the first video on screen, please?
Over the years, the height of key cranes has more than doubled from 25 meters to 60 meters. In order to secure the spreader onto a container, the key crane operator needs to be able to identify the four corner castings of the container and maneuver the spreader's twist of pin to within an accuracy of 5 centimeters from the corner castings in order to land. At a height of 60 meters, it is nearly impossible for a human operator to do this without any technology assistance. PSA and PSA unboxed are looking for a solution that can address this challenge. In addition, the solution should also provide key crane operators with visibility and guidance to move and stack the containers atop each other on the vessel with a gap of no more than 10 centimeters between each stack.
Okay, that's for our first innovation opportunity this afternoon. So maybe we could show the second one as well.
Key cranes are used in container terminals for loading and unloading of cargo at the berth. As the crane becomes taller, it is getting more and more challenging for the key crane operators to safely and effectively maneuver the spreader through the vessel. From a height of 60 meters, human operators seated within the cabin of these key cranes will need to rely on high-definition cameras and LiDAR sensors mounted on the headblock to assist them as they maneuver the spreader through the vessel. Currently, all devices at the headblock transmit data signals through copper wires within the spreader cable. The high current passing through these cables generate electromagnetic interference, making the transmission of low voltage, high-speed signals challenging. Vibration on the headblock and cabin can also introduce unnecessary noise, which further reduces the signal. We have tried adding fiber optic cable into the spreader cable to manage the electromagnetic interference. It works. However, the lifespan of the fiber optics shortens over time, so it is not sustainable. PSA and PSA unboxed are looking for an innovative solution that will improve the speed and quality of the data transmission, maximizing the direct line of sight between the headblock and the cabin. The solution must overcome the challenge of a fully metallic environment.
Okay, so we have shown you two quick videos, and now I hand over time to Boon Teck and Jonathan. Maybe you could introduce yourself and maybe a little bit about what you do and can head directly into the challenge statement.
Hello everyone, I'm Boon Teck from PSA Unboxed, which is actually the external innovation and corporate venture capital arm of PSA International. So our mission and vision basically is to find and use technologies from startups to be applied to our business units. And PSA Singapore is actually one of our business units that we work with. And here we have Jonathan from PSA Singapore. He will share with us the background of the channel shipments. Jonathan, please.
Okay, good afternoon, ladies and gentlemen. Thank you for coming today. I'm Jonathan from PSA Singapore, and likewise, you see, I'm the one that was in the video itself. Okay, just give, in the event some of you are not familiar with what a crane is, because today's two problem statements are all very specifically related to a very specific type of crane, which we call the quay crane. In Southeast Asia, we tend to call it the quay crane. In the Americans, Europe, they tend to call it the ship-to-shore crane. For those that don't know about crane, typically we call it the giraffe crane because it looks like a giraffe when you are driving through. Okay, so this illustration gives a brief introduction of how this crane works, which will give you a little bit more background to the problem statement. Okay. Just to illustrate, okay, this is basically the operator's cabin. In other words, the crane driver will be actually sitting inside this location. Okay. This is what we call the spreader. Basically, this is the thing that will be moving up and down to pick up a container and transfer the container between the wharves on the vessel and onto a trucks. So how the crane works, basically, it goes in this way. Okay, the operator will lower the spreader and then he picks up a container from the vehicle. Okay, then after that, he moves towards the vessel. I just imagine that there's a vessel here. This is basically the water side. And then the operator will land the container onto the vessel. This is what we call a loading operation. Loading operation, basically you load the container onto the vessel. The same operation will be the reverse if you are doing a discharging. Basically, you pick up a container from the vessel and then you land the container onto the truck. And then the truck will shift the containers into our yard. And when we call the lifting height, the term that we use to describe the lifting height is basically the tallest height that the spreader can move, the height of it compared to the ground. Okay, so that's what we call the lifting height. Okay, but when over the vessel, other than the lifting height, there's still an underdeck operation, which can go another 16 meters below sea level. Okay. So the next will be a very short video that will show you the working environment and how the human operator inside this cabin behave when they are so-called doing their job. Just help me to navigate to the next slide. It seems to be not moving. This is a video taken from our overseas. This operator is basically located inside the cabin. Some of the cranes we can set some operation. In this case, when the spreader is moving, there's actually one monitor with that shows the camera view of what the situation is below. But if you realize the operator, he doesn't look at the camera. He doesn't look at the monitor because his core operation he's always looking down. So if any of your solution put additional monitors, it's not going to be very useful. So where you have a bit of idea what the operator is currently seeing. This is the operator at this height is about 50 meters from the ground. That's why certain innovators, this will help the operator, but actually in practical sense, there is no this. Because when we talk to the operator, why you don't use the monitor? But it's very destructive that you keep switching over from the monitor to the actual situation. Because if the event that you're looking at the monitor, the accident happens. For this movement that we call, the majority of the cranes will still be handled by the operator itself. For this particular crane, so-called being retrofitted, hoping to improve the operator's. So that means the initial lowering is operations we are there, and the final part the operator will perform the job. The camera is actually mounted here on top. Because your camera actually you see the spreader itself. I'll explain why it's like that. So again, if you look at the operator itself, his attention is always looking physically down. Okay. So when we say this is a 46 meters crane, so 46 meters means that the the highest height that the spreader is that way can go forward. That means from ground is 46 meters. Yeah. But the human itself definitely because it's located higher. So the human will actually be even taller than that. Just now this gentleman asked, where's the camera of this view? The camera is actually mounted here. There's actually like a platform. So for a 46-meter crane, where you mount the camera is about 50 meters from the ground. Okay. Of course, if you're talking about the vessel, then there's another possibility of going another 60 meters below the sea level. So this is a 46-meter crane, which to our experience, we believe is about the maximum that a human can still operate looking vertically down. Because in order for them to land the spreader onto a container corner casting, the dimension of a corner casting is 18 cm by 16 cm. So the operator will have to maneuver carefully the spreader and land exactly. So if you imagine at 50 meters, you're about more than 20 floor of a HDB flat. And if you look vertically down, you're trying to locate something that's 15 by 18 centimeter. That's what the operator is working. So we do expect the crane to get taller. In fact, the crane are getting taller. Our latest crane in our PSA latest terminal in Tuas terminal has a lifting height of 55 meters. Okay. So at 55 meters, it's going to be very challenging to have the operator to continue to operate from the cabin. Okay, so what PSA is testing at this moment, which we hope to implement full phase in Tuas terminal, is that the operator will no longer be located in the cabin, but he'll be located in remotely in the control center. Okay, so the crane will perform majority of the action automatically, with the exception of the operations over the vessel. This illustration will give you a certain idea. Okay, so this movement, everything will be automatic. We'll pick up the container, move towards the vessel, again is automatic. Then at the final part, a remote operator will be performing the function. Okay. Why the remote operator? Because as mentioned, for Tuas crane, the cranes are 55 meters lifting height. So if the operator will be seated in the cabin, you'll be close to 60 meters from the ground. Then if you add another 60 meters of under deck, he needs to see something as far as about 75 meters away. And that's why we relocate the operator to the remote center. And when the operator is at a remote center, the only view he has are camera views, which will be very similar to what you see earlier, which the next two video will give you another better idea of the type of camera views that the remote operator will be looking at. This is what operating of semi-automated crane. At this portion, the crane is moving on its own, as the operator is not doing anything. And when the spreader is over the vessel, the operator will take over from the remote center and do this. So all the operator can see are through cameras that's mounted. The remote operator has completed the job. He hoists the spreader up, and then the crane will take over and complete the rest of the part, the rest of the job automatically. Yes. inclusive of the operating on the front. Now we have already achieved that. Yes, because for the previous one, you realize that if whatever you do, the operator is not going to use it. Because it's very difficult to change their habit when they have been operating in that way for the past 20, 30 years.
So is the information also, does this person see all the info to decide how to move, maneuver the spreader already? Oh.
I would say as of this moment, the remote operator primarily is just looking at the video transmission. Okay, we do have a lot of additional graphics. As you see, this is actually a graphics that give him additional information, what's the height, whatever it is. But again, basically what the remote operator do is they are, because these are operators that used to operate on the crane. So it's a change in environment, but their primary mode of operating is still very similar. Basically, they are always looking at the target. They have been doing it this way for the past 30, 40 years. When you are trying to land something onto a corner casting, which is only 15 by 18 centimeters, the focus is always on the target itself. So they're always looking at the target and then they maneuver. But when we speak to all these operators, is that the biggest complaint is that when they are situated remotely, they lost all the sense. Because basically, when you are there through their years of experience, they know that now the spreader is at this particular position. If I move my joystick, my spreader is going to swing forward. And they themselves, because when they are physically located in the cabin, as you can see from the earlier video, the cabin is not something that's very stable. So any tiny movement of the joysticks, the operator actually can feel. So they know that what is going to happen next. But when they are located at the remote center, they don't feel anything. In fact, they don't even hear any sound, okay, other than the background music that we play in the remote center. Whereas if they are physically on the crane, when the spreader hit against the container, they can hear a banging sound. So all those sensors, they lost all their sensors when they are located back to the remote center. So despite us trying for quite a few years, definitely the operator will take a longer time to so-called land the spreader onto the container when they are located at a remote center, compared to if a good operator will physically be located in the crane cabin itself.
Do you find though that being able to have an operator sit behind a computer that they can potentially manage 2 or 3 cranes?
Yes. That's actually our long-term objective. Okay. There are a few key objectives. Of course, obviously, ultimately, we want this one operator to be able to man a few cranes. Okay. But there are a few challenges that we need to overcome first. Okay. First is that if we relocate the operator from the local cabin to the remote center, the first target that we need to achieve is that the overall operational productivity of this remote operator crane should be at least equal to if the operator were located on the crane. So that's the first challenge that we are trying to overcome. We have been operating this over the past few years. We are averaging about 2.5 minutes. Whereas if the operator will be located in the physical cabin, our best operator can do within 2 minutes. Okay. So the first step is that we have to provide some assistance to the remote operator so that they can perform as fast as if they will be located locally on the crane. Okay. Then subsequently, because I would say 3/4 of the motion is automated, the operator only need to perform 1/4 of the job. So technically on paper, there's a chance that we only need 1 operator to 4 cranes, but that's our ultimate aim. We hope to reach there, but it's not going to be that easy. But that's actually our ultimate aim. Okay. So the current problem statement is basically how to help the operator. Okay, and again, certain things to take note of. If you provide too much of information, the operator is not going to look at that, because they are always looking at basically this view. Because we can't really be looking at multiple views, and then your brain can't really process multiple views at the same time. The next video will give you a better idea of what the operator is actually looking at when they are operating. Sorry, help me to navigate to the next page. Okay, so this is a day operation. Basically, this is the view of the camera. In other words, the remote center operator, if he's operating, he's looking at this view. This is the primary view that he's looking at. Don't need to pay too much attention on this part because this portion of the job will be automated, but not for this video. When we took this video, this was manually handled to facilitate the video taking. So just pay a bit more attention when the spreader has moved towards the vessel side. Okay, as you can see, these are those on the by the side are the wire rope. Okay, to basically hold on to this to support the spreader. This cable at the center that is flipping badly is what we call the spreader cable that provides the power to all the devices mounted on here. You can see how bad the wire is whipping. Okay, so if this will be a remote crane, this will be the step that the remote operator will take over, and then he will try to land this container to where it is supposed to be. So again, for this video that was recorded, the operator is physically located on the crane itself. Because we want to show you, in other words, with your technology, your remote operator, we hope the remote operator is able to perform in this way. This is a recording where the operator is still physically on the crane. So where he have all the feelings of the vibration, the knocking, the sway of the spreader and all this. Let me navigate to the next page. Okay. So this is how the situation is at night. The actual camera view for the operator is a little better because here is affected because of the lighting that's reducing the contrast. So what I mentioned, how the operator land, basically they have to land the spreader into these four, what we call the corner castings. Because this is what basically support that provides a coupling between the spreader to the container. And the dimension of the corner casting is about 180 millimeters by 150 millimeters. Okay, so just now if you see at the vessel side, I think the operator takes about slightly more than seconds to complete the job. This is with the operator physically located on the crane. If the operator is located remotely away, the time that they take to complete this portion, that means just over the vessel, will range from 30 seconds to 3 minutes. Of course, firstly, depending on the skill sets and depending on the structure of the vessel. These two videos, what we show is basically a very simple scenario because the containers are pretty high up, it's flat. For those who are familiar with how a ship looks like, sometimes you have to operate through a valley. That means the container is still by the two sides. You're just picking up a container in the center. Those are very challenging. So from remote, based on the statistics that we collected over the last few years of this remote operation, it ranges from about 30 seconds to 3 minutes. Okay, so this is a general drawing of our latest crane in Tuas Terminal. Okay, so basically, okay, this is a spreader. So the spreader is 55 meters from the ground. This is the operator's cabin. So a view of the operator's cabin. This is the spreader. So if you were to, all the cameras that you see, the camera recordings, the cameras are actually here. This is the camera. So for a 55-meter crane, this camera will be mounted at a height of about 60 meters from the ground. Then again, at the vessel side, you have to factor in another potential 16 meters below sea level. So the two problem statements that we have is one, okay, how to assist the remote operator to be able to perform their job accurately, rather than just looking at the video itself and using their own gut feel. Because literally they're using their gut feel because they lost all the senses, especially for a very experienced operator. My very experienced operator tells me that he sensed how the wire rope is flipping to know whether it's a spreader moving or not, because he's not looking at the spreader, he's looking at the target. So just through the corner of his eyes, he looks how the wire rope is, he knows where the spreader is. But when you're at the remote center, he said he lost all those senses. He can only look at the monitor itself. So if you have to mount any devices, there are only two potential places where you can mount any devices that you want. One will be at the platform over here. So that's why the problem statements we asking for from a height of 60 meters. Because if you have to mount anything at this platform, it's about 60 meters from the ground. Of course, the other potential query will be, so instead of mounting here, which I still have to overcome these 60 meters, can I mount the device here? Part 3. Today we only have part 2, because if you have to mount any device here, just now during the video, you see that the spreader cable basically is a full copper cable, and the mode operation, you see the cable keep flipping. If you mount any scanners, any sensors, any cameras over here, in order to transmit all those data back, it's very, very challenging to transmit those through copper cables. SPN. The copper cable is also providing power to the motors on the spreader, so there's a lot of electromagnetic interference. Because the cable on top is a slip ring, because it's actually rotating. So it's not a continuous connection. It goes through a slip rings which will generate noise. We have tried, though vendor say, I can produce a spreader cable that consists of fiber optics. Yes, we tried that, but just now in the video, you saw that during operating, your cable is flipping. So if we use any cable that consists of fiber optics in order to transmit all the high-speed data, the fiber optics broke after about 3 to 4 months. So before we go to the stage, I'm going to mount any scanners, any sensor solution to mount on the head block. You first have to overcome the second problem statement first. How can you transmit data? Okay. Potentially, because from the head block to all the way to here, or even all the way to the operator's cabin, there's a direct line outside. So potentially, there certain type of wireless device might be suitable. But if you're using wireless device, as we mentioned in the problem statement, you have to take note of the full metallic environment, because when this spreader is deep in the ship, all the containers are metallic. The ship structures are metallic. So a full metallic environment is not a very good friend to any wireless communication. So that's the challenge you have to take care of. So we are at this stage, right? If you use wired, unless someone can invent a cable that is very, very reliable, which until today, even the best cable supplier is still unable to make that. So if you go wireless, you have to overcome this full metallic environment challenge. But one opportunity is that anything that you mount here has a direct line outside. If you mount, assuming you mount a transmitter here and you mount a receiver here, there's a direct line outside. You can also mount something in the cabin. You also have a direct line outside. So that's something that potentially any interested parties can make use of. Okay. So we are not going to a part 3 of the problem statement to say, can I have my device mounted over here? Because without solving part 2, part 3 cannot work. So today, the problem statements that we are posting is the first part, whether with what technology, but you'll be restricted with any device that you're mounting is only at this place, still 60 meters away from the ground. And second, we are looking for some communication devices that is able to transmit, making use of this direct line on site to transmit data. Because if that is possible, then we can look into in future, maybe 1-2 years later, another problem statement of mounting scanning devices on the spreader in order to do those alignment. Now, because mounting anything on the spreader has a much more challenge. Because when you're operating in a vessel, literally there is no space for any devices to protrude beyond the spreader. Okay, so that's the end of my presentation. Whether is there any questions from the ground?
So can I ask for the remote person, the one viewing the remotely, right? Apart from understanding the vibrations and all this, how real time is the response of the joystick and the video feed at the moment?
Because the camera is mounted over here, so basically the camera signal all the way going back is through fiber optics. So based on our latency test, is about around 500 milliseconds delay in terms of the video. Yeah, but again, 500 milliseconds is from the time that the video leaves the crane. Because nowadays, when you're using IP cameras also have a delay in processing. And that depends on the quality of the IP camera that you have. But basically, once the data leaves the crane, till the time the operator sees remotely, is about 500 milliseconds.
So which one is more detrimental to the remote operator? Lacking of this latency or the lack of feel of the vibrations?
I would say no human can really tell the difference with a 500 milliseconds. So that the operator said they can get used to it. They can get used to it. So now we're basically looking at how can we help the operator from the remote operator by just looking at videos to land. Either they land the spreader onto the container or they land the container onto a container accurately and so-called effectively.
The 500 milliseconds, is it just one way?
One way.
Could you repeat the question into the mic for people who are listening online? Thank you.
So the question was, is the 500 milliseconds just one way or two ways?
One way.
So, okay, so the reason why I asked this is because the moment the operator sees something, right? So there's 500 milliseconds later already. Once he reacts and then he sends something via the joystick, maybe it's going to take another 500 milliseconds to go back.
Yes.
So that's a whole second of delay.
About a second. But again, even physically, if an operator is located on the crane, what he sees is immediate. But his action is also not that immediate. But the operators are quite okay with this 500 milliseconds. And through our experience from other overseas port and through other automated crane, typically, if this latency is less than a second, the operator can get used to it. Even if the latency is more than a second, the operator can still get used to it. But there are some safety concerns because what you're doing is like 1-2 seconds ago. But so far, with everything wired by fiber, the latency is about 500 milliseconds. So likewise, if anyone is thinking of the second problem statement and you're installing wireless devices, that again will add to the latency.
Maybe any further questions from the ground? If not, maybe I could check if there are any questions on Zoom. Okay, just want to remind those who are on Zoom as well, you can just key your questions into the chat box as well. Yeah, so thank you for this presentation. It's very insightful. Just wanted to ask, because you did mention that it kind of operates in a very metallic environment and something, solution providers should consider when they provide a solution. So just wondering maybe what kind of other considerations they should take into account when coming up with a solution.
The metallic environment is basically, through experience, I believe definitely quite a few of you here are experts in wireless comms. A metallic environment is always something very challenging. For those that are thinking of using laser scanners, okay, something that I forgot to mention earlier. Okay, let's say for example over here, what you see is actually 2 containers on the vessel. Sorry, this is 1 container. Let me. Okay, help me to go back 1 slide and play the video. Something to take note is that the way that the containers are being stacked on the vessel, basically the containers are being stacking immediately next to each other. Also they're touching. So this gap is only 10 centimeters. So if you're using any sensory device, your sensory device have to be able to detect this 10 centimeter gap from a height of 60 meters away. It's very challenging using just laser scanners. And that's basically the bottleneck that why this key crane or ship-to-shore crane have not been automated after so many years. Okay, because the most common laser scanners that's being used in the port technology and the port industry, which I won't mention the name today, does not have the resolution to detect this 10 centimeter gap from a distance of 60 meters away. Okay, PSA we did. Currently are working with one boutique laser manufacturer, which again, I will not mention the name. So they have one product that on paper might have the capability. So we are already testing with that device itself. So if in the event your proposal is also using the same device, then very sorry, we will have to reject your proposals. Okay.
Okay, actually, I have one more question for you because startups are trying to create a solution to solve this challenge statement. So maybe you could share a bit more on what support the startups could get from working with you, because I'm pretty sure this is something that they look forward to as well.
Yeah. Definitely PSA will provide access to the crane. We will work together with you to do testing on the crane. But that's provided if we think that your proposal is something that potentially can work. In fact, some of you here have been working quite closely with us. We get to know some of you through previous years of SPC as well.
Okay, so if there are no further questions from the ground, I just wanted to ask you one last question, because you did really share a lot, but maybe you could share maybe summarize in 3 sentences what startups should actually note when solving this challenge statement. Just a quick summary.
Basically, we are providing these problem statements in this Smart Port Challenge, even though we are working with a lot of crane system integrators. But crane system integrators have a very certain mindset. They always think that only laser scanners can be trusted. So by the fact that we are posting this here, we are open to test any new technologies. In fact, in some, especially European countries, they prohibit using video analytics for safety reasons. But in PSA Singapore, at this moment, we are more open to testing to new technologies to see whether what other technologies might be able to overcome these problem statements, which the typical crane system integrator will not be using.
Okay, I think maybe we can wrap up today's session. So I just want to thank you again for sharing in such detail and also giving a lot of videos, which is very helpful in actually explaining the problem. Yeah, so maybe we could go to the next slide, please. Yeah, okay, so Smart Port Challenge actually open until the 8th of July. So you can scan the QR code on the screen and submit your applications. And if you want to learn more about other innovation opportunities that we have, you can also scan the other QR code on the screen. Yeah. Next slide, please. Yeah, so we also have upcoming roadshows with other corporates next week, which include Clafness, Jurong Port, Wilhelmsen, as well as OHC Shipping. So do sign up for those if you're interested in those challenge statements as well. Yeah, finally, we have our last slide for today. So you can continue to follow us on LinkedIn as well as on our mailing list to get the latest updates. So thank you those who are joining us online today. And I think we can begin the networking session for those who have joined us in person today. Thank you.